This is day 1 of Unit 7. So we started today with a warm-up. So pause the video, try this warm-up. These should be kind of basic exponent problems from Algebra 1 and geometry. So take a moment and try those. So the first one, I just multiply here. Now, common student mistake would be to distribute that 4. There's no plus signs here between those terms. So don't distribute the 4. The 4 just kind of stays there. I don't know why that's not working because I just turned the pen on. Okay. So the 4 just stays there, and then we have the v's to combine. The rule that you learned in Algebra 1 says that when you're multiplying like bases, you add the exponents. So 4 plus 1 is 5, and then u cubed, and that is your final answer. Number 2, you're going to simplify the numbers. 4/8 we know is 1/2. Then the variables. The rule says subtract the exponents when you're dividing like bases. So 4 minus 2 is positive 2. Positive tells you that it belongs in the numerator. On the other hand, if you get a negative number, we know that you can't leave negative exponents in your answer, so then you'll move that to the denominator. So that happens with the n. So 3 minus 4 is -1. I don't want to say n to the -1. I want to say n to the positive 1 in the denominator. Same thing with the p's. -2 minus 3 is -5. That means p to the 5th power belongs in the denominator. So that would be your final answer. In previous classes, that's probably what you said for your answer. We know, though, anytime we have variables in fractions, we need, or in the denominator fractions, we need domain restrictions. So m, n, and p all cannot equal 0 because of the original and the final answer. The denominator can't be 0. So that's your final answer. So today was just some practice with some just taking those properties and combining them. So the first one here, make sure you get that in your notes. So I know I don't distribute that 2. There's no plus signs. I just keep the 2, but I can combine the x's and I add those exponents and get x to the 12th. In the denominator, I know that I'm going to, first of all, square the 4 to get 16. Secondly, when we have something to a power, you learned the rule is that you multiply the powers. So that gives me x to the 6th. That's not simplified because I have x's over x's and I have 2/16. So I know 2/16 is 1/8. I'm going to put the 8 in the denominator. Wow, I'm not sure if I need the 1 yet. Let's see if we get anything else in the numerator. So x to the 12th over x to the 6th, or divided by x to the 6th, subtract the exponents. 12 minus 6 is positive 6. That's going to be x to the 6th in the numerator because it's positive 6. And because that x to the 6th is there, I don't need the 1. Only need to write the 1 if there had been nothing else in the numerator. So x to the 6th over 8th is my answer, and then restriction, x cannot equal 0. Next one, so copy that one. So I'm going to follow order of operations always on these, which means I'm going to simplify the exponents first, meaning square 2a, meaning 2a times 2a, which is 4a squared. That's going to be multiplied by 3b, the quantity cubed. 3 cubed is 27, and b cubed is b cubed. And then that's over 10a to the 4th b squared. So let's simplify the 4 times 27, or if you want, simplify the 4 over 10. Either way, we can either multiply first and then simplify, or simplify first and then multiply. So 4 times 27 is 108, a squared b cubed over 10a to the 4th b squared. So 10 divided by, or 108 divided by 10 is a decimal. You don't want decimals, but you can simplify each of those numbers by dividing by 2, which gives me 54 in the numerator and 5 in the denominator. Simplifying the a's, a squared over a to the 4th, 2 minus 4 is -2, which means a to the positive 2 goes in the denominator. And 3 minus 2 for the b's is b to the 1st, and that's positive, so b to the 1st goes in the numerator. Restrictions, a and b both can't equal 0. Next, copy that one. So we just talked about in the last couple problems negative exponents. If there are negative exponents in the numerator, we know to put the same base to the positive exponent in the denominator, well, we need to talk about what happens if the negative exponent's in the denominator. So again, you just take the reciprocal of the base. The easier way to think of that, though, is just to move that, whatever is to the negative exponent, move it to the numerator and make it to the positive exponent if it was in the denominator. If it was in the numerator, it goes down and loses the negative, and if it was in the denominator, it moves up and loses the negative. So I'm going to do that. So that means that quantity 2n moves down, and now it's cubed instead of to the negative third. And you just have to be careful here. The 4p is not in parentheses, which means the only thing that's to the negative exponent is the p. So the 4 stays there, the p moves up and changes to a positive 2. Next, I'm going to simplify the parentheses. So I'm going to take 2n and cube it, means 2 times 2 times 2, n times n times n, which of course is 8n cubed. Then I'm going to simplify further by multiplying. So I'm getting p squared over 32n cubed. And I have p's over n's. That doesn't simplify, so I just need my restrictions. From the final answer, n can't equal 0. From the original denominator, p can't equal 0. That's my final answer. So the next one's similar, except for the negative exponent is applied to the entire fraction. The base is a fraction, which means we need the reciprocal of the whole base. So that means the numerator becomes the denominator and the denominator becomes the numerator. And when we do that, when we get the reciprocal of the base, we then change it to a positive 2. So then from there, I just square the quantity 4x, which is 16x squared. And I square the quantity 3b, which is 9b squared. And 16 and 9 looks like nothing in common. X squared and b squared, nothing in common. Just need my x and b not equal to 0 for the restrictions. And that's the final answer. That's a 0. And the last one we did for today. So I had students copy this one and then I told them to try it. So you might want to pause the video, try it first, and then play to check your answers. So first thing I need to do is the switching around the negative exponents, move them to the opposite place. The 4 is not to the negative exponent, so the 4 is going to stay. So the entire quantity x to the 8th, y to the 6th moves up to the numerator, and it's now cubed. And the entire quantity 2x, y to the 6th moves down to the denominator, and it's now squared. So I'm going to apply the next property, which says I multiply the exponents. So x to the 24th and y to the 18th. And the 4 stays there. 2 is squared, which is 4. And x is squared, and y is to the 12th. So then that's x to the 24th, y to the 18th, over 4 times 4 is 16, x squared, y to the 12th. And now we can't leave x's over x's and y's over y's, so the 16 stays. 24 minus 2 is 22, that's positive. And 18 minus 12 is 6, and that's positive. So I have x to the 22, y to the 6 over 16, and x and y both cannot equal 0. Okay, that's it for today. So your assignment for next class is pages 3 and 4 in your new Unit 7 packet. And then you do have a quiz coming up next week on exponents. So you need to fill in that chart that you were given in class and memorize those exponents for next week's quiz. There will be 10 problems in 2 minutes.